It slowly grew last time, so. All right, so we're on lecture 30. We're going to talk about, continue our discussion of polynomial functions and their graphs. So we have this polynomial here, 0.005 times x minus 5 times x minus 10 times x minus 2 times x plus 3 times x plus 7. So before I go and answer these questions about it, first, what is the degree of that polynomial? Fifth, yeah. If I multiplied it all together, I'd be multiplying x times x times x times x times x. So it would be an x to the fifth. So I have fifth degree polynomial here. Now, if I were to set this polynomial equal to 0, what would my solutions be? Jody Ann, you're on fire. -3, -7. Good. So those are the x values that would make the polynomial equal to 0. What are the zeros of P? The same numbers, right? Zeros is just the word we use that means the solutions to where the polynomial equals 0. Okay, so it would be 5, 10, 2, -3, 7. What are the x-intercepts of this polynomial? Same thing, yep. These are the x values, the y coordinate would be, so we'd have 5, 0, 10, 0, 2, 0. So we write those ones down a little bit differently sometimes. Sometimes we just use shorthand and write down the x's for x-intercepts. Factors, what are the factors of this polynomial? Yep. We don't have to do any work for that. It was written all in factored form, right? We've got x minus 5, x minus 10, x minus 2, x plus 3, and x plus 7. It is. Sure, we can list that as a factor. It's something that you multiply. So yeah, we'll count it as a factor. When you're solving these, yeah. Yeah. So the reason I didn't list it is because the point is that I'm trying to make with making you write all these things down 4 times is that they are almost the same thing.
It's probably a really stupid question, but why are
So this is the original polynomial, right? So this is what you were given. And when you try to solve where okay. Okay. That's okay. So the factor theorem essentially says that all of these 4 things are the same. Being a 0, being a factor, being a solution, and being an x-intercept are all almost exactly the same thing. Like if you know one of them, you know all of them. I think so. I have never understood what, sometimes when I do that, the recorder stays up and sometimes it hides behind. I don't know why. So yeah, it says that all of these are the same, that if you know that C is a 0, you know x minus C is a factor. If you know x minus C is a factor, you know C is a 0. So like it can go in either direction. If you know x equals C is a solution, you know C is a 0 and x minus C is a factor, etc. If you know one of them, you know all of them. So knowing zeros, knowing factors, knowing solutions, knowing x-intercepts are all knowing the same thing. So I want to use the factor theorem to decide if x minus 2 is a factor of that cubic polynomial. So deciding if something is a factor is kind of a difficult question, right? Like if I say, to find it directly is kind of difficult. If I say, you know, is 5 a factor of 30? Is it? Yes. Well, how do you know that? Right. It divides in evenly, or because 5 times 6 is 30, right? So that's how we know it's a factor. So to know if x minus 2 is a factor, to answer that question directly would be to say, does x minus 2 go into this cubic polynomial evenly, right? And we don't know how to divide polynomials yet. But we could say, well, I'll know x minus 2 is a factor if 2 is a 0. So instead of checking if x minus 2 is a factor, let's check and see if 2 is a 0. X minus 2, a factor, is the same thing as x equals 2 is a 0. So we can check that quickly. So if I plug a 2 into my polynomial, 2 cubed plus 2 times 2 squared minus 2 minus 10, what am I looking to see if that equals? 0. So let's say I've got 8 plus 8 is 16, minus 12 is 4. So 2 is not a 0, which means x minus 2 is not a factor. So we have a quick way to tell if if certain factors go into larger polynomials. Check the 0 instead. So for part B, so this one I used knowing the 0 to see if a factor. Now I'm going to try to find the factors. So an easier thing to do than to find the factors is to find the zeros. So I know that 2x squared minus 3. Well, I'm going to start by factoring out the 2. And now I want to find the 0. So ideally, I want to write this as 2 factors. So I want to factor that. So what I need are the zeros of x squared minus 3 halves, because that's what goes there. This is going to be x minus, and the things that go in those empty spots are the zeros of the polynomial. Okay, so let's see. I want to set x squared minus 3 halves equal to 0, and I get x squared equals 3 halves. So x is what? Plus or minus the square root 3 halves. So then I plop those in as the positive square root of 3 halves and the negative square root of 3 halves. You could, yeah. So back when you learned how to factor, if that was on a test, like in your intro algebra class, that would have been a hard question to factor, right? Now we can do it pretty quickly. Find the zeros, you got the factors. Which part? Okay, so the idea is I'm trying to write 2x squared minus 3 as a product, something times something else, right? So first thing I did is I factored out the 2 because it's easier to factor things that have a leading coefficient of 1. So I factored out the 2, and I got this. And then I said, okay, my goal is to take that x squared minus 3 halves and write it as a product. So I wrote the empty parentheses with x minus in them. And then I said the things that go here in the empty spots are the zeros of x squared minus 3 halves. So found the zeros, plugged them in. Mm-hmm. All right, so we have a few different approaches to factoring or to finding the zeros of polynomials. So if it's quadratic, you can use the quadratic formula. We can use a graphical approach because you can find the zeros by having your calculator find them in the calculate menu. Choose option 1, 0. And then we have factoring, right? But factoring is hard enough for second degree, and it gets harder and harder as the degree gets higher. So let's say I wanted to find the zeros of x cubed plus 2x squared minus x minus 10. Higher the degree than 2, which means it's going to be hard to factor. And it turns out that there actually is a cubic formula analogous to the quadratic formula. And it's in your notes there. I didn't put it on here, but it's a mess. You do not want to have to deal with that. So instead of using that really intimidating formula that's going to be very time consuming, we're going to generate a graphical / algebraic approach. So we're going to use both the calculator and some algebra to come up with all of the zeros of this polynomial. So first, we graph it. Okay, so we type in the formula x cubed minus x squared minus 24x plus 48. And I'm just going to do a standard window because I don't have any context. So often we take the context from a problem to guess it a good window. But since I don't have anything to go on, I'm just going to start with the standard window, zoom 6, and hope I see a good 0. So it looks like I have 3 zeros in the window. I've got 3 zeros. It looks like one of them goes through a nice, pretty point, a nice, friendly integer. Which one do you suspect is a good 0? 4, yeah, x equals 4. So you just kind of go 1, 2, 3, 4. And then you can check it by looking at the table. Type in 4, we get 0. We know 4 is a 0. You can also get it by doing second calculate, option 2, find the 0, and you would get x equals 4. Okay, so our nice solution is x equals 4. To calculate 0? I didn't finish it. You have to give a left bound and a right bound and a guess. All right, so now we have one solution. We're going to find the other two. I could do the second calculate 0 thing again on the other two. I could do second calculate 0, give a left bound. Right, I already know the one at 4, so I'm trying to find this next one to the left. Left bound, right bound, yes. And I get 2.2749172. And that's actually an estimate. It's just an approximate value. Or I can't assume that that's an exact value, right? It's clearly a decimal. It might have cut off, that might be the exact value, but it might have cut off decimals that wouldn't fit, right? I can't tell. And I only know that that 0 exists because it happens to be in the standard viewing window. It could be like way out at -50 and I wouldn't even know it was there. So I'm not going to depend on my calculator to find these other two. The first one is fine because it's just a nice, I know 4 is the actual 0 because I can check it. I can plug a 4 in here and I get 0. Okay, so I could use the 0 command. This gives us only approximate answers, and it only works in this case because I can see the other two x-intercepts. So instead, I'm going to move to a more algebraic approach. I now know that 4 is a 0, which means what factor do I have? If 4 is a 0, I have what as a factor? X minus 4. Great. So 4 is a 0, x minus 4 is a factor. Now, before I use this information to help me find other factors, we're going to discuss quickly what it means to be a factor. All right, so 22 is a factor of 2,970. What does that mean? Yes. So there are a couple of ways to think about it. You can say, well, 2,970 divided by 22 is a whole number, right? Or you can think of it as you can get 2,970 as 22 times a whole number. So those two mathematical sentences really say the same thing. Take the one on the left, multiply both sides by 22, and you get the one on the right. So this is what it means to be a factor, right? Is that that the number is evenly divided. 2,970 is evenly divided by 22. All right. So moving back to our polynomials. X minus 4 is a factor of x cubed minus x squared minus 24x plus 48. That means I can write my polynomial as x minus 4 times something. Just like 2,970 could be written as 22 times something. This is what it means to be a factor. So x minus 4 is a factor. So how could I find out what the stuff is? Divide both sides by x minus 4. Okay, so it turns out that another factor you can get by division. X cubed minus x squared minus 24x plus 48. We get this other factor by dividing. The same thing you do with numbers, right? If I wanted to get the other factor, k, 2,970 is equal to 22 times something, divide both sides by 22. Okay, so without a calculator, I want to do that. I want to figure out what do you multiply 22 by to make 2,970. No calculator. So what do I have to do? Break it down how? Oh, you want to do like the prime factorization? Yeah, that you could, but that would take, that's more work than is necessary. I want to know 22 times what? We'll call this thing k, right? 22 times what is 2,970? Just going to divide both sides by 22. To do that division without a calculator, I think that's why you were thinking prime factorization. But I'm going to use the standard long division algorithm. Okay, so I want to do, maybe I'll do it on the next page so I have plenty of room. 2,970 divided by 22. And the reason I'm forcing you to do long division is because that's how we're going to divide polynomials. Because your calculator can't do polynomial division like it can with numbers, so we have to remember how this works. Anybody remember? What do I do first? Yes, okay, so you ask yourself, does 22 fit into 29? Why didn't you do like 22 into 297? What if the problem was like this? So I asked myself, how many times is 35 going to 20? Okay, yeah. Good. So the important distinction that you have to make there is that first we're comparing this digit to this digit, right? And 22 is less than 29, so I'm looking at the 22 and the 29. And you say, okay, well, how many times is 22 going to 29? And it is once. Okay. So the first thing to compare is the leading digit. Okay. So that's 1 time. And then what do? Multiply the 1 by the 22. And then you subtract. And you subtract, remember the long way, you do 9 minus 2 is 7, 2 minus 2 is 0. Bring down the 7, and then you just start the whole process over. 22 goes into 77 6 times. 3 times. I was thinking about the answer. 3 times 22 is 66. And then I subtract. 7 minus 6 is 1. 7 minus 6 is 1. Bring down the 0. 22 goes into 110 5 times. Now we use this word goes into. I'm going to rephrase it so that it'll make more sense when we do it with polynomials. Instead of saying 22 goes into 110 how many times, I'm going to say 22 times what gives you 110. Same question, I just phrased it differently, right? So 22 times 5 gives you 110. So I'm going to put the 5 here. 5 times 22 is 110, 0. And once you get a number down here that's smaller than 22, you know you're done. And if it's 0, it went in evenly. All right, so that means that 2,970 can be written as 22 times 135. All right, so when we do division with polynomials, it's going to work almost the same. But instead of digits, instead of the thousands, hundreds, tens, and ones place, we have terms. We'd have like the cubic term, the squared term, the x term, and the constant term. All right, so polynomial division is going to work very similar. I want to do p of x divided by x minus 4. So x cubed minus x squared minus 24x plus 48 divided by x minus 4. So think of the x minus 4 as like the tens place and the ones place. So the first thing I want to compare is the tens place here to the tens place here. So you say, okay, well, what would I multiply x by to make x cubed? X squared. X squared. So that's the equivalent of how many times does x go into x cubed? Just ask it a little differently because you go, I don't know how, like, but rephrase it as multiplication, it makes more sense. So x times x squared is what gives you x cubed. So I line up over the x squared's place. Then you multiply x squared times your entire thing, x squared minus 4. So x squared times x is x cubed, and x squared times negative 4 is negative 4x squared. And then you get a subtract, right? So do each one. Negative x squared, remember that we're subtracting this whole thing here. So I have negative x squared minus negative 4x squared. So what does that come out to? Negative 5x squared. And x cubed minus x cubed is 0. Those go away. Then we bring down the minus. Yeah.
Negative 1 squared.
Oh, you're should be 3. Yep. Thank you. Negative x squared minus a negative, that's really a plus. So that's negative 1 plus 4, which is 3x squared. Then bring down the minus 24x, and we start the process over. So we look at the leading term here, like the tens place, and you say, well, what would I multiply x by to make 3x squared? 3x. So I put plus 3x up here. And then I multiply 3x times x minus 4. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. And I have to subtract. Okay, so 3x squared minus 3x squared, those go away. Then I have negative 24x minus negative 12x. So that's negative 24x plus 12x, which is negative 12x. Then bring down the 48. So now you ask yourself, you just start again. What do you multiply x by to make negative 12x? Negative 12. Then multiply the negative 12 times the x minus 4. Negative 12 times x is negative 12x. Negative 12 times negative 4 is positive 48. Subtract, and we get 0. Remainder 0. So we found another factor. If we knew x minus 4 was a factor, just divide it into the polynomial and you get another factor. It might not be the most reduced possible, but it's still better than we had before. X squared plus 3x minus 12. So we get p of x. We now can write as x minus 4 times x squared minus 3x minus 12. And x squared minus 3x minus 12 is a quadratic. I can factor a quadratic. Which one? Yep, plus 3x, thanks. Quadratics are sometimes factorable, and even if it's not, I can find the zeros by using the quadratic formula. So does that thing factor? Minus 6, no, I don't think it factors. So if I want to continue to factor it, it's going to look like this. And then I have to put the zeros in there of x squared plus 3x minus 12. So I use the quadratic formula to do that. And I get x equals negative 3 plus or minus the square root of 3 squared minus 4 times a times c all over 2. So we have negative 3 plus or minus the square root of 9 plus 48, which is 57 all over 2. So those are my two other zeros. And all I have to do is just plop them in right there. Negative 3 plus root 57 over 2, and negative 3 minus root 57 over 2. And now we've written it in completely factored form. So here's completely factored form. My 3 zeros are those two. And the first one I found, x equals 4. So what do you think? You like it? Okay. Yes. Just doesn't quite all fit on one screen. Probably the best. So let me steal this for 1 second. Before we move on to the next topic, I want you to go to the factoring polynomials activity and work on number 1C. Do 1C on your own. So it's just like the one we just did. Find a factor graphically, then divide it out to find the remainder. All right, so now I do the division. So I have to ask myself first, what do I multiply x by to make x cubed? X squared. Okay, now x squared times x gives me x cubed, and x squared times 2 gives me 2x squared, and I subtract. X cubed minus x cubed is 0. Negative x squared minus 2x squared is negative 3x squared. Bring down the negative 5x. Then you start again. What do you multiply x by to make negative 3x squared? Negative 3x. Multiply it out. Negative 3x times x is negative 3x squared. Negative 3x times 2 is negative 6x. Subtract. The 3x squareds cancel. Then I have negative 5x minus negative 6x. So it's really like plus 6x. So I have negative 5 plus 6 is just x. And then I bring down the plus 2. And x goes into x plus 2 once. 1 times x plus 2 is x plus 2. Subtract 0. So there's my other factor. I now know that my polynomial can be written as x plus 2 times this result. Minus 5x plus 2. X squared minus 3x plus 1. Okay. Now, my goal is I want to write this as 3 linear factors, right? X minus, x minus, x minus. I know this one is x plus 2. And now I want to break the x squared down into 2 linear factors. X squared minus 3x plus 1 doesn't factor easily, so I have to find its zeros. And I do that using the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2, which is 3 plus or minus root 5 over 2. So there's a typo in my answer. I had these as negative 3 plus or minus root 5 over 2. So then I take these zeros, plop them in here, and I have factors. 3 plus root 5 over 2 and 3 minus root 5 over 2. So I have 3 factors, which means I have 3 zeros, these two, and x equals negative 2. Okay? Any questions? All right. So you can do some of those other ones in a couple minutes. We're going to move back to the lecture, the next topic. So the last thing that we're going to talk about is zeros that have higher multiplicities than 1. So multiplicity just means the number of times that you get that solution when you set p of x equal to 0. So if I set f of x here, 0.01 times x plus 3 times x plus 3 times x plus 3 times x minus 2 times x minus 2 times x minus 4 equal to 0. So I just took my polynomial. I wrote it all out like, oh, I mixed up which ones had 3 and which one has 2. There we go. So x plus 3 squared, that just means x plus 3 times x plus 3, and x minus 2 cubed means x minus 2 times x minus 2 times x minus 2. Just writing it all out the long way. So when I'm trying to solve this equation, so first thing I might do is just divide everything by 0.01 to get rid of that coefficient. And I'm going to have left with 1, 2, 3, 4, 5, 6 linear factors, which means how many zero, what's the degree of that polynomial? 6. Good. So when you have a long string of things multiplied together and the answer is 0, we usually take the shortcut and just write down the solutions, but what we're really doing is setting each factor to 0 when solving, right? So I get x plus 3 equals 0 twice, x minus 2 equals 0. I'm going to write this all vertically. 3 times. And then I have x minus 4 equals 0. So when I solve these, I get x equals negative 3, x equals negative 3, x equals 2, x equals 2, x equals 2, and x equals 4. So instead of writing down x equals negative 3, x equals negative 3, instead of writing it down twice, we write down x equals negative 3 with multiplicity 2. That's all multiplicity means. So when I list my zeros, I write x equals negative 3, and I just put down multiplicity 2 next to it, meaning that was a factor twice. X plus 3 was a factor twice, so x equals negative 3 is a 0 twice. And I would say x equals 2, it has multiplicity 3. And x equals 4 has multiplicity 1. So that's what a multiplicity means. It's just how many times you get that 0 when you're solving. And remember, zeros are where x-intercepts are. So negative 3, 2, and 4 should all be x-intercepts of this graph, and they are. But they're different looking x-intercepts. They don't all look the same. Okay, so this one at negative 3, if I zoom in on it, I'm going to do a fancy little thing here. If I zoom in on that x-intercept, what kind of function does that look like? Quadratic, yeah. It's got the end behavior of a quadratic or a 4th degree or a 6th degree. It looks like an even degree polynomial, right? Both arms up. That signifies when you get that kind of behavior near an x-intercept, that signifies an even multiplicity, right? It looks like an even degree polynomial. It signifies even multiplicity. And we, in fact, did have multiplicity of 2 at that 0 at negative 3. And if I zoom in on this x-intercept, what kind of polynomial does that look like? Yeah, a cubic. I mean, a negative cubic. Yeah, it's got the end behavior of an odd degree polynomial. One arm up, one arm down. So when you have this kind of behavior near an x-intercept that looks like an odd degree polynomial, you know you have an odd multiplicity. You don't know which one. You don't know if it's 3 or 5 or 7, but you just know it's odd. And then for this last 0, when I zoom in on that, oh, that was a bad zoom. That kind of looks like a straight line, right? Which is what degree polynomial a straight line? 1. So when it goes through the 0 looking like a straight line, that signifies that 0 has multiplicity 1. Okay, and at 4 we did have multiplicity 1. So summary, odd multiplicity, any odd multiplicity will go through the axis. Even multiplicity will bounce off, right? It'll hit the axis and come back the other way. And if you have multiplicity greater than 1, it kind of stalls out on its way through, right? So here's a graph of a polynomial function. I want to write out a possible equation for it. So let's just write out its zeros. Okay, so list off the zeros for me for this polynomial, or the x-intercepts. -2, 0, and one more. 1. The x-intercepts are at -2, 0, and 1. And then we're going to put down possible multiplicities. Okay. Possible multiplicities. They ask for a possible equation. So we can know something about the multiplicities from the graph, but not everything, right? So any of these x-intercepts look like just a straight line through the 0. Which one? The one at 0. Yeah, it just is a straight line right through the x-axis. So this one we're going to say is multiplicity 1. Now, the other two, let's look at the 1. Because it bounces off, what do we know about the multiplicity of that 0? It's even. That's all we know. We don't know if it's 2 or 4 or 6 or whatever. But we know it's even. And if I'm trying to come up with a possible equation, I'm just going to choose the easiest even, the smallest even. I'm working on the wrong one. Thank you. I know it's even, and I'm just going to choose 2 because it's the easiest. It's the smallest even number. And then when I look at the -2, it doesn't go right through, right? But it doesn't go straight through, but it does cross through the axis, which means what about the multiplicity? Odd. So I know this one's odd. I know it's not 1 because it doesn't go through like a straight line. It kind of like stalls out, flattens out as it goes through. So I'm going to choose 3 because that's sort of the easiest, the smallest odd number to work with. If this was a test question, you could have chosen 4 for the even and 5 for the odd. It doesn't, you can't know exactly unless I gave you more information about this polynomial, right? If I told you that it was 6th degree, then you would have been able to figure out the multiplicities exactly. So a possible equation would be y equals, for each 0, you have a factor, x plus 2, and that has to be a factor how many times? 3 times, because -2 is a 0 3 times, so x plus 2 is a factor 3 times. And then x is a factor because 0 is a 0. And x minus 1 is a factor because 1 is a 0. And it's multiplicity 2, so it's a factor twice. So there's a possible equation. We could throw any coefficient in front of that. Put a 5 in front and my zeros would stay the same. So you could put a coefficient in front. These degrees could be a higher odd or a higher even. What do you think of that? Any questions? Mm-hmm. Yes. It's for evens and odds. If you had, say, a 4th degree or a multiplicity of 4, so here's multiplicity 2. What one of these might look like. Looks like a quadratic, which is just going to be like something like that, right? And then multiplicity 4, a higher degree, might look like that, where it's flatter. But you can't really tell from the graph. We just know that the higher the multiplicity, sort of the flatter this gets, the longer it takes to go up. All right, so I'm going to have you work on the rest of this activity.